Hi, in this video we will just practice and improve our skills in solving derivatives. So, here we go. So, example number 1, we have y equals to 2 all over the cube root of x plus 3 cosine x. Then, we can rewrite it into y equals to 2 times x raised to the power of negative 1/3 plus 3 cosine x. For the solution, we have 2 multiplied to 1/3 x raised to negative 4/3, and the derivative of x is 1 plus 3 multiplied to negative sine x. So for the final answer, we have y prime equals to 2/3 x raised to the power of negative 4/3 minus 3 sine x. In this problem, we apply the chain rule and the derivatives of trigonometric functions in order to solve this problem. If you have not yet watched the lessons about differentiation rules and derivatives of trigonometric functions, link on the description below. So let's proceed to the next example. We have y equals to x squared tan x. So for the solution, we have y prime equals to x squared second squared x plus tan x times 2x. So for the final answer, we obtain y prime equals to x squared second squared x plus 2x tan x. In this problem, we apply the product rule and again the derivative of trigonometric functions of tan. Example number 3, we have y equals to negative 4x squared e to the x plus 5x e to the x minus 10 e to the x. And for the solution, we have y prime equals to e to the x times negative 8x plus quantity negative 4x squared times e to the x plus e to the x times 5 plus 5x e to the x minus 10 e to the x. Next, we have negative 8x e to the x minus 4x squared e to the x plus 5 e to the x plus 5x e to the x minus 10x e to the x. And for the final answer, we obtain y prime equals to negative 3x e to the x minus 4x squared e to the x. Example number 3, in this problem, we apply the product rule and the derivatives of exponential function. Example number 4 is y equals to ln x squared times quantity x plus 1 all over quantity x plus 2 raised to 3. And using the properties of logarithmic function, we get or we rewrite into y equals to 2 ln x plus ln of quantity x plus 1 minus 3 ln of quantity x plus 2. So for the solution, we have y prime equals to 2 over x plus 1 over x plus 1 minus 3 over x plus 2. First, we find the LCD, which is the x times x plus 1 times x plus 2. So we have now 2 times x plus quantity x plus 1 times quantity x plus 2 plus x times quantity x plus 2 minus 3x times quantity x plus 1 all over x times the quantity x plus 1 times the quantity x plus 2. So we expand the equation by distribution, then we obtain the final answer of 5x plus 4 all over x quantity x plus 1 times x plus 2. So example number 5, we have y equals to cosine x plus e to the x minus 2 arctan x plus ln x minus 3 raised to 5x. For the solution, we have y equals to cosine x plus e to the x minus 2 arctan x plus ln x minus 3 raised to 5x. So for the final answer, we have y prime equals to negative sine x plus e to the x minus 2 all over 1 plus x squared plus 1 over x minus 3 raised to 5x times ln 3 times 5. In this problem, we simply solve the derivatives of each of the terms. Example number 6, we have y equals to tan times 5x squared plus 3 all over 2x squared minus 1. Now, for the solution, we have y prime equals to the quantity second squared 5x squared plus 3 all over 2x squared minus 1 times 2 quantity 2x squared minus 1 times 10x minus quantity 5x squared plus 3 times the 4x all over the quantity 2x squared minus 1 squared. So for the final answer, we have y prime equals to second squared 5x squared plus 3 all over 2x squared minus 1 times the negative 22x all over the quantity 2x squared minus 1 squared. In this problem, we apply the quotient rule and the derivative of the tangent. So for our last example, we have y equals to 4 raised to 5x squared arcsine x all over cotangent x. First, we will rewrite the equation. So we have y equals to 4 raised to 5x squared times 2 arcsine x times sine x all over cotangent x. Then we have ln of y equals to ln of 4 raised to 5x squared arcsine x all over cosine x. Then ln of y equals to 5x squared ln of 4 plus ln of arcsine x plus ln of sine x minus ln of cosine x. So next, y prime over y we have here equals to 10x ln of 4 plus the 1 over the square root of 1 over x all over arcsine x plus cosine x over sine x minus negative sine x over cosine x. And for the final answer, we have 4 raised to the power of 5x squared arcsine x all over cotangent x times to the 10x times ln of 4 plus 1 all over the square root of 1 minus x all over arcsine x plus cotangent x plus tan x. And this problem has a quite long solution, but we solved it. If you find it confusing, I have an example problem on the previous lesson about the derivatives of the logarithmic and exponential function, link on the description below. Before we get to the final answer, we multiply the equation by y, leaving y prime on the left side. Then the value of y is simply the problem itself. That's the end of our lesson about the derivatives of the functions, and for the future topics we will probably discussing its application, so stay updated by subscribing this channel and turning on the notification bell if you wanted to be updated for the latest videos that will be uploaded. So stay tuned and keep subscribing. Thank you.